Hello. Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techniques. We believe that sharing of the knowledge is the key to enhance our skill and to grow us as the professionals. With this principle in the mind, we have initiated a series of the webinar conducted by the industry expert to give you all a scripts inside of the various domains. The topic of today's session is the software testing series, importance of the matrices in the software testing. Our guest speaker today is Mr. Avneet Singh, Product Development Manager, Engineer Technologies. Avneet has over 14 years of cross-functional experience in the software testing. He has a diverse experience in the working in the startup as well as large organizations like Aon Habits, Mahindra Satyam, Global Logic Equac, where the earned numerous award certifications. He has been instrumental in the setting up and the development of the highly cost-effective teams from the scratch of the software, quality testing, test automations, and the technical consulting. Currently, Navneet is working as a product development manager in Engineer Technologies and is responsible for the developing complex scalable system. He is accountable and the result-driven strategic professional who excels at the managing project, collaborating with the project teams, interfacing with the clients, and the developing technology to build successful solution for the clients. So, without further delay, I introduce to all you our guest speaker. Over to you, Mr. Avneet.
Thanks for the introduction. I'm just sharing my screen. I hope you are able to see my screen now. All right. So the topic for the day is the importance of matrices in software testing. So I would be taking this session in a matter of 1 hour, and after this, whatever the queries you have, you can just send in your questions, and I would be able to respond to your all your questions. So starting with the importance of matrices in software testing. So here is the agenda for the day. We'll start with defining the software matrices. What are these matrices? Why do we actually require to measure software? And then what are the importance of matrices? And then we'll go through the entire matrices life cycle. And then we'll go over the types of various software testing matrices. In these types, we would have manual testing matrices. We would have automation matrices, we will have performance, and then the common matrices. So starting with the software matrices, what are these matrices? So we'll first of all evaluate these matrices. So Tom DeMarco has said that you can't control what you cannot measure. So in order to control, you have to measure that where are you exactly and where you want to be. So with this, we'll go over the definition of software matrices. So Paul Goodman has defined a software metrics as the continuous application of measurement-based techniques to the software development process and its products to apply meaningful and timely management information, together with the use of those techniques to improve that process and its products. So if you see this definition, it is written in a bit complicated way that you may or may not understand. So going towards a more descriptive version of this definition is the measurement. This is software matrix is a kind of measurement-based technique which is applied to processes, products, and services to supply engineering and management information, and working on the information supplied to improve the processes, products, and services. So this is an entire workflow which has been defined by Paul Goodman. Moving further, why should we measure software? We should measure software to determine the quality of the current product or the process. Because if I say that what is the quality of the project that I'm working on, what is the current quality and where I want to achieve, I will not be having a definite answer until and unless I measure this software and I feel that okay, this is at level 1 and I want to achieve it to level 2. So it also predicts the qualities of the product and process. So if we are going at a constant rate, it can provide a definitive figure that by the end of this release or by the end of around 3 releases, where would be the quality of this software would lie. And then it also helps us to improve the quality of our product or process. If the defect retention rate is very high, we can see what all factors can be done to achieve the same, to achieve a target. Now coming towards the importance of matrices. So matrices is used to improve the quality and productivity of products and services, thus achieving the customer satisfaction. So like I had mentioned before, we can improve our products and services, the quality of those products and services, and then we will definitely be achieving the customer satisfaction. The next importance is for, it is very easy for the management to digest just one number and drill down if required. For example, if I say that in this particular software, we have a very high rate of defects. In that case, we would the management would just drill down and see what is causing these defects. We can do a RCA, that's the root cause analysis, and then we can figure out where the exact problem lies, and we can easily solve that particular problem. The next point over here is different matrices tend to act as monitor when the process is going out of control. So we, as you all know, that while developing a new, developing any kind of project, there are lots of processes which are interrelated. So if one of these processes is going out of control, we can easily find out by using the matrices, which I can explain in my in my forthcoming slides in a more better way. And then matrices provides improvement for the current process. So it's already related to the same point which I've discussed above, that whatever process that we are working on, we can easily improve it by the help of these matrices. Now let's come to the matrices life cycle. So what is matrices life cycle? It's similar to a normal software development life cycle, but it has its own parameters. For example, the first step is analysis. In this analysis, we identify what are matrices we need to use. We define those matrices because each matrix has some standards, and then we need to set that particular matrix within our own working environment, and we need to define these matrices. And then we need to define the parameters for evaluating the matrices defined. We would have a benchmark figure for each and every matrix, that if this matrix crosses this particular figure, then we are good, and if the matrix figure is below our industry standards, in that case there is some problem which needs to be analyzed. So all these steps comes under the analysis cycle. The next stage is the communicating stage. So once we have defined the matrices, now the next step is to communicate these matrices to all the stakeholders. So we need to explain the need of matrices to the stakeholders as well as the testing team which is involved. And then we need to educate, especially the testing team, about the data points that we need to capture in order to process a particular matrix. Once the communication is done, the next part comes the evaluation, and this is the most important part of this life cycle. Once we have we need to capture all the data, we need to verify the data, and then we need to calculate the metric value using the data captured. So this calculation is very important. If we commit any kind of mistake in capturing these data points, in that case the entire matrices will not have a much good use for us. And the last part of the life cycle is reporting. We need to develop the report with effective conclusion. We need to have the picture in black and white. Either it's good or it's bad. And if it is bad, we need to dig out some points to resolve it. And if it is good, then we are okay. Then we need to distribute these reports to all the stakeholders and the representatives. We need to flash that okay, here we are, this is the quality of the software. And then we need to take the feedback, optimum feedback from the stakeholders. We need to be very effective in this. And if we get a feedback that this particular area is a weak point, we need to work hard on that particular area, and we need to get the results out within a short span of time. Now we can come to the various types of software testing matrices. So basically, we have divided these matrices into these 4 areas. The first one is the manual testing matrices. The second one is the performance testing matrices. Third one is automation, and then the last one is the common matrices, which are very, very common. And I'm sure that you all must have gone through all these matrices. So since this is a session which is specifically for software testing, and so that's why we'll be talking about all these testing matrices in these 4 areas. So if I go through very briefly, I would be talking about each of these matrices in detail during the course of my presentation. But just to give you a brief idea of all the manual testing matrices, first of all, we would have a test case productivity. So this test case productivity matrix would provide the information for the number of steps which are written per hour. So over here we can find out the productivity rate of the testing team members that we have. The next one is the test execution summary. So this matrix provides a statistical view of the execution for the release along with the status and the reason for that. So we can easily get that what was the execution rate that we performed in a particular release. The next one is defect acceptance. It indicates the stability and the reliability of the application. The next one, that all the defects which you had logged, so they were accepted by the development team and they were actually resolved. The next one is defect rejection. Suppose you have logged a high number of invalid defects, so that defeats the purpose of a testing. So it provides a percentage of all the invalid defects. Then we have a bad fixed defect. So this particular matrix indicates the effectiveness of the defect resolution process. The next one is test execution productivity. This provides a detail of the test cases which are executed per day. Then we have test efficiency, which indicates the testing capabilities of the tester in identifying the defect. We have defect severity index, which provides the indication about the quality of the product under test and at the time of the release. So this was about the manual testing. Then we have around 6 matrices for the performance testing. So these are basically the performance scripting productivity, which provides the scripting productivity of the performance test flow. Then we have the performance execution summary, which provides the classification with respect to the number of tests conducted along with the status, either pass or fail, for various types of performance testing. Then we have the performance execution data, and this is divided into client side as well as the server side. So for the client side, it will give us the detailed information of the client side data for execution, and for the server, it will give us the detailed information of the server side data for execution. The next one is performance test efficiency, which indicates the quality of the performance team in meeting the performance requirements. Moving forward, we have performance severity index, which would indicate the severity of the test. And then moving on to the automation part, we have around 4 matrices that we have defined. One is automation scripting productivity, which indicates the scripting productivity of the automation test script. Then we have automation execution productivity, which provides the execution productivity per day, which is quite similar to the test execution productivity in case of manual testing. And then we have a automation coverage and cost comparison. So these basically provides the how much test we have covered, how much test we have automated, and then it will the cost comparison will give us a return on investment on the tool that we have used. Moving forward to the common matrices, these are very common matrices: effort variance, schedule variance, and scope change, which you might have used in the course of your career in software testing. So we would look into all of these matrices in detail. So first of all, we'll start with the manual testing matrices, and the first matrix is test case productivity. So as I described before, the test case productivity metric would give us a test case writing productivity based on which we can have a conclusive remark. I would explain it in more detail. The formula for calculating the test case productivity is the total raw test steps divided by the effort which we had put in order to create those steps and multiplied by steps per hour. So I can tell you this example, the particular formula with the help of an example. Let's take the example of these test cases. We have 5 test cases, and each test case have these number of steps. So for example, test case 1 has 30 steps, test case 2 has 32 steps, 3 has 40, 4 has 36, and 5 has 45. So in total, we have a total 183 steps. And the effort that is required for writing this 183 steps is, let's suppose it's 8 hours. So we can easily calculate the test case productivity by just dividing the number of steps divided by the number of hours. So since we took 8 hours to develop 183 test steps, so our productivity is 22.8. Or you can say that we can actually write 23 steps per hour. And then once we have developed this particular figure, then we can compare it with the same metric for a period of time. For example, right now we are sitting in June. We have a device rate of 23 steps per hour. However, in the month of May, we were able to work only 20. We were able to produce only 20 steps per hour. And in the month of April, we were doing 19. So gradually, this shows that we are improving in our execution, in our scripting process month by month. Moving on further, the next metric that we can talk about is test execution summary. So test execution summary would give us a classification of the test cases with respect to the status, along with the reason, if available, for various test cases. It gives a statistical view of the release. So this view that is being displayed belongs to a particular release. So we can select the data for the number of test cases which were executed with this particular status. That is the pass status, the fail, and the reason for failure also, and then unable to test. So there might be some ways that we are not able to test. For example, we due to some kind of time crunch, or there was a defect which was not fixed, it was postponed. There was some kind of setup issue, or some tests were taken out of scope. So due to this, there might be some of the test cases that are out of scope. So in all, we can find out what is the test execution summary for, and then we can also compare this. So the next one is defect acceptance. So this metric determines the number of valid defects that the testing team has identified during the execution. The formula for this is that the defect acceptance is equal to the number of valid defects divided by the total number of defects multiplied by 100, since we are calculating a percentage. So if we see the trend, so this is we can compare the trends month by month. That, for example, in the month of April, the defect acceptance rate was 80%. It increased to 90% in the month of May, and then in June it declined a bit to around 89%. So we can have this kind of trend analysis done for the defect acceptance rate. So in this particular rate, the higher the number of defect acceptance rate, it is good for the organization. Now the next is defect rejection. So this metric determines the number of defects that were rejected during the execution. So the formula for this is number of defects which were rejected divided by total number of defects into 100. That is also a very simple formula, which is quite similar to the defect acceptance rate. And then based on this analysis, we can have a trend analysis also, which can show us month by month. That, for example, in the month of April, we had a 10% of defect rejection, which increased to 12.5% in May, and then reduced a little bit to 12 in the month of June. So we need to, our main target is to reduce this particular defect rejection rate to a minimum. The next matrix is bad fix defect. So there are some defects whose resolution would give rise to some new defects. For example, we have logged a defect in module A, and once that defect was fixed, the fix for this defect uncovered two more defects in the same module, which were previously working fine. So that is a result of a bad fix. So this metric determines the effectiveness of the defect resolution process. That is, defect resolution process, is it effective or it is not effective. So the formula for this is the number of bad defects fixed divided by the total number of valid defects into 100. So this is also calculated as a percentage. Then we can have this trend analysis that in the month of April there was a 0 bad defect rate. It increased to 2 in the month of May, and then it gradually decreased to 1 in the month of June. So this was the bad fix defect. The next metric is test execution productivity. So this is the most important metric which I feel that gives us a very good result. So this metric gives the test case execution productivity, which on further analysis can give some conclusive results. So the formula for this is it is the total number of test cases executed divided by the execution effort in hours multiplied by 8. Since we need to execute, we need to find out the numbers per day. So we are taking an average working rate of around 8 hours in a day, and therefore we are taking this, we are multiplying this by 8. So moving forward, so what is total number of test cases executed? So there is another formula for calculating this total number of execution rate, that is TE. So it is equal to the base test case plus we have another category. For example, we have this number of test cases retested. So this is T into 0.33. This is another string which I am just showing you over here. So the base test case is the number of test cases executed at least one. So this is the full test case which is executed. T1 is the number of test cases retested with 71% to 100% of the total test case steps. For example, we are able to test at least more than 71% of the test steps in a particular test case. So we classify it as T1. Then we have T.66, which determines that the number of test cases retested with from 41% to 70% of the total test case steps. So we actually, all this is a averaging factor. So T.66 is an averaging factor, and the next factor is T.33, wherein it determines the number of test cases which were retested with less than 40% of the test case steps. So what we are doing is we are just calculating a weighted average of all the execution weights to give us a great detailed information. So the test case execution rate would be the base test case plus the product of T33 into 0.33. We are averaging it out. Then plus T66 into 0.66. This is also averaging, and then T1 into 1. So this would give us an adequate rate. So I can explain this with the help of an example also. So suppose this is a sample of 5 test cases, and if you see the second column, it says that base run effort, that is in terms of hours. Test case 1 is 2 hours, 2 is 1.3 hours, 3 is 2.3, 4 is 2, and 5 is 2.15. Then we have this rerun status. So in the first round, we executed around 40% to 70% of the test case steps of test case 1. That's why we have defined it as T.66. In the second test case, we were not able to execute more than 40% of the total test steps. That's why we had defined it as T.33. For test case number 3 and 4, we were able to achieve the retesting rate of more than 71% to 100% of the total test steps. So this is the run for the first run. The similar data is displayed for the second run, and the similar is for the third run. So for every for every status, we would have the effort in hours. So test case 1 for the first run, test case 1 took 1 hour, 2 took just 30 minutes, 0.3 hours, 3 took around 1.2 hours, and 4 took around 2 hours. So this has all the calculation done for 3 test runs. So now if we accumulate these calculations, so we can see the base test case has 5 runs. T1 has 4 runs, T.66 has 2 runs, 0.33 is 1, and then we can calculate the total effort in hours. In order to give you a deep understanding of how this this T1 came out was 4. So how can we calculate this as 4? We can just simply count that T1 was done in number 3, test case number 3 in first run, test case number 4 in first run, then test case number 2 in second run, and then test case number 1 in third run. So this is 1, 2, 3, and 4. So we can easily get a figure of 4. Similarly, T.66 is being displayed only 2 times, 1 and 2. So that is the value of 2. And 0.33 is just being displayed 1 time. So that we have calculated. And then we have calculated the total hours, the effort in hours belonging to all of these values. And then this total comes out to be 19.7. So once we have find the total effort in hours, we can just simply put in the formula that we had described in the last slide, this particular formula, and then we can get this result. So this is TE is equal to 5 plus 1 into 4 plus 2 into 0.66 plus 1 into 0.33, which comes out to be 10.65. And then we can simply divide it by 19.7, which we have the total effort, and then multiply by 8, and then we can have a rate of 4.3 execution per day. So over here we can find out the productivity rate of the test execution. For example, one person can execute 4.3 test cases in 1 day, as per this particular example. Once we have this figure, then we can compare it with the trend during if we see from the past 1 quarter. For example, in the month of April, a person was able to execute only 2 test cases, and then in the month of May, it increased its productivity from 2 test cases to 4 test cases, and then in the month of June, that is in the current month, a person is able to execute 4.3 test cases. So this is a very important metric, and which works wonders in most of the countries, most of the companies where we have seen the implementation. The next one is test efficiency. So this metric determines the efficiency of the testing team in identifying the defects. It also indicates the defects missed out during the testing phase, which migrated to the next phase. So this is also very good metric if you want to find the failure rate of the testing team. For example, in this particular formula, we have this test efficiency to DT. DT means number of valid defects which were identified during the testing, divided by the total number of defects, that is the number of valid defects plus the number of defects which were identified by the user. For example, in the UAT phase. So this was the number of defects identified in the testing phase divided by the total number of defects both in the testing as well as the UAT phase or the acceptance derive a percentage by multiplying by 100. So this is the formula for calculating the test efficiency. And the test efficiency should be a very high figure. It should be somewhere in more than 95%. In that case, it is good that the defect leakage is just around 5%. And the less the leakage, the more it is better. The greater the test efficiency, the more it is better. Now moving forward, we can have this trend analysis in the test efficiency that in the month of April, it was 98%. Then in the month of May, there was no defect leakage and the test efficiency was 100%. That is a very good figure. And in the month of June, it came down to 97%. So we can have this kind of RC activity, that is the root cause analysis for this by taking into account this type of matrices, that what can be done to achieve a rate of 100% and why this particular rate falls from 100% to 97%. So we can do a root cause analysis for these defects. The next one is defect severity index. So this matrix determines the quality of the product under test and at the time of the release also. And this is based on that we can take a decision for releasing the product or not. So this is also a good matrix wherein it tells us what is the defect severity index, and then it can be calculated by a summation of severity index into number of valid defects for this particular severity. The severity index can be simply a number from 1 to 5, ranging 5 to be a very critical defect, and the 1 is less in severity. So this can be divided into two parts. One is for the all status and the other would be just the open status. So let's take the example of the first one, that is the DSI for all status defects. So this will include the defects for all the status. It might be open, it might be new, it might be closed, and it would take this analysis for all of these status defects. So for example, there were around 5 defects which were low severity, 7 defects were of a high severity, 8 defects were, 7 for medium, 8 for high, and then 10 defects were the critical severity defects. So the DSI for, if you put these figures into the formula which I had explained in the earlier slide, so you can get the DSI for all status as 2.8. The next part is the DSI for open status defects. In this, the formula is that severity index multiplied by the number of open valid defects for this severity. We will exclude all the defects which have been closed. We would also exclude all the invalid defects. So what are the current defects which are open as of now? So we can see that the DSI for open status is 3 in this particular example, which have 1, 1, 1 in a low, medium, and high, and there are 3 in the critical stage. And then we can have this kind of analysis trend that all status was 2.8 and open status was 3. So currently we have more critical defects which are still open, and then we need to reduce this particular count so that we should fix all the critical severity first, and then we can fix the low severity defects afterwards. So these were all the manual testing matrices. So we have done with all the manual testing matrices. Now let's move to the performance testing matrices. So what are these matrices? So as we had explained earlier, these are the 6 matrices that are there in the performance testing: performance scripting productivity, performance execution summary, performance execution data, which is client side as well as server side. Then we have performance test efficiency, and then performance severity index. So we'll just go through it very quickly one by one. First one is performance scripting productivity. So this metric would give us a scripting productivity for performance test script and have a trend over a period of time. The formula for this is performance scripting productivity is equal to operations performed divided by efforts in hours. and that would come as operations per hour. So what are operations performed? There can be number of clicks on which the data is refreshed. For example, you are clicking a refresh button, you are clicking an add button or an edit button wherever the data is being changed. The number of input parameters, how many input parameters are you actually entering it into a system, and the number of correlation parameters. For example, entering by one parameter, there is a corresponding change in some other parameter. So all of these things are treated as the operations. So we can take a very simple example in this case also. For example, this for the number of we have recorded these operations. For example, the number of there were 10 clicks that were performed. There were 5 input parameters and 5 correlation parameters. So if we calculate the total number of operations performed, it was 20. And the effort for performing these 20 operations was 10 hours. And then we can simply divide it by 10 and we can have a figure of 2 operations per hour. So this performance scripting productivity will have 2 operations per hour. So we can also have this trend analysis wherein in the current month it is 2. However, in the previous month it was 1.8 and then in April it was 1.5. So we can have this kind of analysis by using this particular figure. Next one is performance execution summary. So this metric gives the classification with respect to the number of tests which were conducted along with the status, that is either pass or maybe fail, for various types of performance testing. So some of these types of performance testings are, let's say for example, peak volume test or endurance or soak test, breakpoint or stress test, and or failover test. And then once we have defined these parameters and then we take those values, we can easily do a comparison by in this particular way or method. For example, there were around 5 test cases which we had done on peak volume test, out of which 3 were passed and 2 were failed. Sorry, or two were passed and 3 were failed. There was 1 test that was passed, endurance test was 2, 1 passed and 1 failed, and then 1 failover test was passed. Moving on to the next part, it is performance execution data, which is client side. And the following are some of the data points for this metric. Like we had data points for the earlier metric. For the client metrics, we have running users, we have response time, we have hits per second, we have throughput, we have total transaction per second, we have time to first byte and error per second. So these are some of the parameters which we can evaluate in performance execution data client side. Similarly, the next one is for the server side, the performance execution data for server side, and these are the data points that we can capture. For example, the CPU utilization, the memory utilization, the heap memory utilization, and the database connections per second. Moving on to the next metric, that is performance test efficiency metrics. So in this, this is the metric which determines the quality of the performance testing team in meeting the requirements which can be used as an input for further improvisation. And this is a formula, that is the requirement met during the performance test minus requirements which were not met during after sign off of the performance test divided by the requirements met during performance test. And then we can multiply it into 100 by getting the percentage figure. So in order to evaluate, I'll come to the example later. In order to evaluate this particular metrics, we need to collect the data points, as there was data points in the previous example. This metrics also have the data points. For example, some of the requirements of the performance testing may be the average response time. So what is the average response time of this particular transaction, or the transaction per second? How many transactions can be performed per second? Then, or maybe the kind of there may be some kind of other area like the application must be able to handle predefined max user load. For example, if I am creating a website, I can have around somewhere around 5,000 simultaneous users. So my application should be able to handle these many simultaneous users. Or some kind of server stability. That what is the stability level of my server? Is my server crashing every now and then, or what is the uptime of the particular server? So all of these things can be explained with the help of this example. So consider that during the performance testing, the above mentioned requirements were met. All these requirements which I've just highlighted. The requirements met during the performance test was 4. In production, the average response time is greater than the expected, then the requirements are not met after sign off. That is equal to 1. So, so out of the total of 4 requirements, 1 requirement was not met. So the performance test efficiency would be 4 divided by 4 plus 1 into 100. That would come out to around 80%. So for in this particular case, the performance test efficiency is 80%. We can have a trend analysis also, that in the current month it was 80%. However, in the previous month we were able to meet all the requirements. It came to 100, and in the month of April also around 1 requirement was not met, so it came to 96. So this kind of trend analysis can also be done in this performance efficiency trend. The next one is performance severity index. So this matrix would determine the product quality based on the performance criteria on which one can take a decision for releasing the product to the next phase. That is, it would indicate the quality of the product under test with respect to its performance. So the formula for this is severity index into the number of requirements not met for this particular severity divided by the total of requirements not met. So if the requirements is not met, so one can assign the severity of the requirement so that the decision can be taken for the product release with respect to the performance. Suppose if there's one, for example, the page load time fails, that when just around 40 users log into the into that application, the application just crashes. So I would consider this as a very high severity, and then we can decide whether or not to release a particular software without fixing this particular issue. So in this case, I've taken another example that the average response time is an important requirement which has not met. Then the tester can open the defect with severity as critical. In that case, the performance severity index would be 4, which is very much critical. So this was, we can show it we can have this graphical representation where there is just one critical defect which has a performance severity index of 4. So that was all about the performance testing. Now we have a third category of matrices, that is the automation testing matrices. So all the folks who have been doing the automation in their respective companies, they might have come across these matrices, and these are also very good and effective matrices in terms of automation. So the first one is automation scripting productivity. So this metric would give the scripting productivity of automation test scripts based on which we can analyze and draw most effective conclusion from the same. So we have a formula for this matrix. This formula is automation scripting productivity is equal to the operations performed divided by the effort in terms of hours. So this can be further defined as this operation performed is the same that we had discussed earlier, that is the number of clicks or the clicks on which the data is refreshed, number of input parameters, and the number of checkpoints added. Because in automation, this is a very important parameter while adding the checkpoints, because for every control, we would have some kind of checkpoint which would do all the field level validations and every such thing. So this is is also included in the operations performed. If you take an example, in a particular uh, release, we have this operations. For example, the number of clicks were 10, number of input parameters were 5, number of checkpoints added was 10. So the total number of operations performed was 25. And the effort that took for creating these 25 operations was, let's suppose, 10 hours. So ASP, or the automation scripting productivity, would come out as 2.5. So automation, it means that we can, any tester can work at a speed of 2.5 operations per hour. So this is also very useful metrics for defining the automation effort that is needed, and whatever the effort that you basically confirm to the client. So it's advisable that you follow this kind of methodology. Here is a trend analysis. You can compare this particular rate month by month and can see how effective your testing team is. And since it is a constant increasing, so every month the productivity of the testing team is actually increasing. It is 2.5 at this point of time. It was 1.8 earlier, and then 1.5 the month before. The next one is automation test execution productivity, that is AEP. So this metric gives the automated test case execution productivity. So this is very similar to what we had already discussed in the manual testing, that was the manual test productivity. So the formula is absolutely the same. Instead of manual test cases, it's just an automated test cases, and the entire evaluation process is very much similar to the manual test execution productivity that we had discussed before. So I will not go into much detail in this. It's just very same formula. It's the absolutely same formula. Just you take into account all the automated scripts, all the automated test cases instead of the manual test cases. The next one is automation coverage. So this particular metric gives the percentage of manual test cases which were automated. So this is a very important metric, and this is a very, very basic metric in case of automation testing. It has a very simple formula, that is the total number of test cases automated divided by the total number of manual test cases, and you multiply it by 100 in order to derive the percentage. So let's take a very simple example, that if there are 100 manual test cases and you have actually automated 60 test cases out of these 100, then the automation coverage will be 60%. The more the coverage, the better automation is being implemented in that particular project. Now the last metric in case of automation testing is the cost comparison. This is a metric which is very useful for the management of any company, as this metric would give us the cost comparison between the manual testing and the automation testing. It is used to have a conclusive return on investment, or ROI. So this can be calculated as shown in this slide, that the manual cost is evaluated as the execution effort in hours multiplied by the billing rate of the resources. And we can compare to a comparison with the automation, and then these are the cost aspects of automation. That is a tool purchase cost, that is a one-time investment which you have made to acquire a particular tool. Plus we would have the maintenance cost also, where it includes the support cost from the vendor. Then we have the script development cost. So this script development cost would be nothing but the execution effort in hours multiplied by the billing rate. So if you add all of these parameters, you get a cost of A, or that is the cost of automation. Then you compare it with the manual cost, and you can determine that by automating what is the cost comparison that you have. If there are more number of cycles, the cost comparison, the cost A will be very much less than the cost M. So that would provide a solution that you should go in for automation instead of manual testing. So that was for the automation. Now the last expect over here is the common matrices. So these are the very common matrices which you have used, and I will not go into much detail of these common matrices. The first one is effort variance. Effort variance is nothing but actual effort minus estimated effort divided by the estimation effort. So you can get what is the effort variance that you have. Suppose estimated effort was 100 and you actually increase it to 105. So you have a very good effort variance because it is a positive. And suppose it was a negative, in that case that is taken as a bad thing. That effort variance you had estimated as 100 and then you were able to achieve only 95. So that would be a negative value. Then we have schedule variance. It is almost in a similar lines where that it takes the number of days or into account instead of the effort. So that is the actual number of days minus the estimated number of days divided by the estimated number of days. And you can take a percentage. You can also do a trend analysis, like what was the estimated days and what was the actual days. You can actually derive this in a graphical representation. Then the next one is scope changes. So the scope change indicates how stable the scope of the testing is. So the scope should be very much stable. It should not change very frequently. So it can be calculated as a total scope minus previous scope divided by the previous scope into 100. And then we can have this graphical representation of this scope change. So this covered all the matrices that are very important and especially in the field of software testing. So this is just a recap of all the matrices that we had discussed so far. We had manual or performance, automation, and common matrices, and we had discussed all of these matrices in detail. We had given examples, and these matrices should be utilized in every software product to actually cross-check where we are and where we want to go. And if there are any negative or adverse values in any metrics, we should do an appropriate RCA, that is a root cause analysis, and we should determine that what are the factors which are preventing us to be where we want to achieve. So this was all about the testing matrices, and just let me know if there are any questions. I will be available to answer all your queries at this point of time. Please submit your questions so that I can answer the questions. Okay, so I've got a few questions. So first question was asked by Ranjit Prashant, that what is a single word definition of metrics? Metrics is nothing. If you want a single word definition, then it's a measurement of the software. It's measurement. So what is the Excel formula of matrices? So I've given all the Excel formulas. Ranjit, you might have seen during the course of my tenure. Next question is from Neha, how to calculate severity index. So severity index is nothing but the values given to the severity fields. For example, high is maybe 3 or 4, critical is 5, medium is 3. So this is the kind of the severity index. Then the next one is how will I come to know the severity index like any formula? So like I've just explained that you can have any severity index assigned. The next one is shall we measure matrices before execution of the test cases? Well, that depends on what type of matrix you are going through. If you want to have a test creation matrix, yes, you can define this matrix before executing. But if you want to find out the test execution metrics, then you have to wait for the execution to be over. Another question by Ranjit is, I've given the answer to the formula for metrics. Yeah. How can we improve metrics report on a daily basis? So on a we should not use metrics reports on a daily basis, but you should uh, calculate it on a regular basis. For example, in all my examples I've shown is as a monthly calculation. So you, depending on the project that you have, you can do either a monthly calculation or a weekly calculation, or if the project is very small, which would last a couple of days only, then you can do a daily calculation. The next one is it possible to edit the matrices after delivery? What do you want to edit? Because you can edit the matrices, the values will always be different. So if you are evaluating a metric in the month of, let's say, April, you have the same formula. You can put in the new values for the month of May and new values for the month of June, and then you will get all the other values. So uh, it is possible to edit the matrices, if I would say in this particular way. So the next question by Durga Priya is, what are the matrices used to evaluate a software tester? So software tester is the one matrix that is very common is the defect acceptance rate and the defect rejection rate. So these are the two values matrices, and all the manual testing matrices which I had spoken before can actually talk about the performance of a software tester. You as a tester, if you are a tester, it would be very beneficial for you to maintain these matrices so that you can show your achievement and show your performance as compared to the others in your team. And for an organization also, it is good that they can actually get some kind of quantitative data on the matter that which a team member is working good and which team member is not working up to the expectation. So the next question from Ranjit Prasad is, matrices come under QA or QEC or both? Well, that would actually depend on the matrices. There are some matrices which are just the quality control aspect, but some matrices have a very broad vision which would come under the quality assurance matrices. The next question from Sumati is how to calculate scope change metrics. So I've discussed that. See, in the scope change matrix, what happens is that you have a matrix, you have a defined scope in terms of maybe some kind of document like, say, function specifications. So if the scope changes on a regular basis, suppose you had around 100 functionalities, and then the scope changed to around 150 functionalities. So you have a scope creep of around 50 more functionalities. So that from that angle, if you put these values into the formula which I had explained before, you can actually calculate the scope change. The next one is, what is 8 in AEP? So in AEP, let me just go back to the slide. I guess my sharing is paused, so I'm not able to show you the. Okay. Oh, I'm not able to find 8 in AEP. So you're saying ASP. Okay, here it is. Okay, this 8. Okay, now I got a question. So this is the number of working hours in a particular day. So so we have an assumption that this question was asked by Ravi Sinha. So Ravi, we had asked, we have taken a value of 8, that is a common venture that whenever we are estimating the number of hours in a day, we actually take 8 hours. So in a normal circumstance, a person works only for 8 hours in a day. So that's why we have multiplied by 8 in order to get the value, in order to take the value as per day. Next question is, what is a bad fixed effect? So a bad fixed effect is a you can say matrix which would tell us that suppose you have suppose that the development team has fixed a defect, and that defect was not properly fixed, or the fix of this particular defect resulted in outcome of some other defects. So that is called a bad fixed defect. So that was asked by Naveen Kumar Raju. So there's another question, what is valid defect? So a valid defect is a defect which is valid and that should be fixed. So a valid defect is a defect which is actually a defect. Chaitanya has asking a question. Okay, that's a compliment for me. Thanks a lot for a wonderful session. Thank you very much. The next question is how to calculate scope change matrix. So I've explained earlier that the scope change matrix can be calculated by the difference in the original scope as well as the change scope, and then you can calculate this matrix. The next one is when we calculate cost for several cycles, how is the tool cost taken into consideration? Asked by Sridhar. Let me read the question again, that when we calculate cost A for several cycles, how is the tool cost taken into consideration? Okay, the tool cost is taken into the consideration as the market rate of a tool. For example, you have to automate in using the tool that is QTP. So you should take the market rate of the QTP. What is the per license cost of the QTP, and how much and how many licenses do you actually require in your product? So that determines the actual tool cost. The next question is from Chetan, that can you please explain automation coverage and automation cost metrics once again? Okay, so automation coverage and automation cost metrics. So see, the automation coverage is very simple, that out of the total number of test cases, how many test cases you have actually automated. For example, you have a total of 100 test cases and you had automated 60 out of those 100, so you have a good rate of 60% of automation. And the automation cost metrics is that you are just comparing the actual cost incurred in automation by the actual cost which would have been incurred in the manual testing. So I've given you the formula. I'll just go to that particular slide. Here it is. So this is the rate. This is the formula for calculating the manual cost. That is, you just multiply the execution effort by the billing rate, and then for the automation, you would need to add the the cost of the tool plus the maintenance cost and plus the script development cost. That is the execution hours into billing rate. So the next question is can I have the PPT? Yeah, sure. You can just mail me at my email ID, which is mentioned in my last slide. That is amin.singh@engineer.in, and I will be able to send you the PPT. So you just have to assign a value. There's no formula for that. Next question is from Ravindra Joshi that what do you mean by test steps and why it took 2 hours to execute a test case? So that it took 2 hours because that was an example which I took. It can be just around 30 minutes. That depends on the test case, the complexity of the test case. Some test cases are very complicated, which would take more than 2 hours, and there are some test cases which can be executed in just 10 minutes. So that is just an example which I have taken. The next question is from Satya that difference between qualitative metrics and quantitative metrics, and which ones are qualitative. So all the matrices need to be quantitative because for the qualitative matrices you cannot judge the quality of the application. You have to bring everything in figures so that you can compare. If I say that this the execution rate was very good, and by the term very good, that is just some kind of qualitative. I cannot quantify. I have to quantify it in terms of numbers. If it is 8, it is good. If it is 5, it is not good. So that is so we need to bring everything into some quantitative figures. The next question is from Pradnya that hi, it was a very informative and useful. Can we get a copy of this presentation? Yes, sure. Please mail me and I can give you a copy of the presentation. The next one is Amrish Kumar. Do we include the metrics in test plan? And it is client deliverable. So yes, you can include the metrics. Like I had informed you in the metrics lifecycle, communicating to the clients and all the stakeholders is very important. And then if you put the metrics in the test plan, you can actually tell them that these are the matrices which we will use to evaluate the quality of the software from time to time. But the results of these matrices would not be included in a test plan. This should be communicated to all the clients in some kind of separate communication. Next question is from Naveen Kumar that could you re-explain test execution productivity? Yeah, sure. I can explain that. Test execution productivity is nothing but what is the rate by which you can execute those test cases. If I go back to the slides, I can quickly explain this particular. This is the formula for this. That is the total number of test cases executed divided by the execution efforts in hours multiplied by 8. So that is the rate of executing the test cases. And in order to calculate the TE, that is the total number of test cases executed, you can actually break them into various test steps. That, for example, if there were around 100 test cases and out of which you had executed only 50, and for the rest of the 50, you might have executed some of the steps wherein you felt that after around for example 6 to 7 steps, the test case failed. So your effort also consumed in testing those 6 to 7 steps. So it is taking into consideration all the effort that you had actually put in executing a test case, and then it is taking a weighted average of that particular effort, and it is just dividing by the total number of execution efforts, and then multiplying 8 by to fetch out the value of execution per day. I hope that you have understood. If not, then you can just mail me with the details and I can explain you further. The next question is from Satish that what is the difference between test efficiency and DRD? So test efficiency is basically for the test cases, and DRE is basically for the defects. So both of these matrices are equally important. Next question was from Shushma that how can we measure the matrices when the test coverage in manual testing is harder due to system issues or the bugs we produce. So Let me read the question again if I have understood it correctly. How can we measure the metrics when the test coverage in manual testing is harder to do? See, the main objective of this test case of this particular metric is how much percentage of the test cases you have automated. There might be some issue in executing, maybe due to a particular defect, which would be fixed shortly. Maybe it's not fixed now, but it might be fixed a little bit later. But how much of the percentage of the test you have automated? The execution is this matrix does not depend on the execution part. It is just the scripting part which is actually important for this particular matrix. So Ajay is asking that when we calculate this matrix in SDLC. So in SDLC, these matrices can be calculated at almost all the phases depending on the matrix. And suppose if you're calculating the execution rate, it will be done in the execution cycle. And if you are calculating the creation part, then it can be done in the designing or development. Neha is asking a question that if a software has 2,000 bugs, then how to justify your customer that you will provide a good software after testing, and how many are quality test cases? So in this particular example, since there are 2,000 defects, I am assuming that they must be open. So you can actually categorize it by the severity, that out of this, how many are the critical severity, how many are for the low severity bugs. So I'm sure out of these 2,000, only around maybe 30 or 40 would be critical, and the rest would be a low severity. So if you show the client this kind of picture, that out of these 2,000 bugs, this is a severity-wise distribution, so I guess the client would appreciate the effort that you are putting in. So the next question is, on what basis we select the metrics? So that it depends on what objective you want to achieve. So if you want to do a defect analysis, then you can then you should take in all the defect matrices, and if you're doing some test case analysis, then you should work on the manual test cases matrices. Next question is from Midanju, that usually who will be handling the matrices? Will it be test lead or test managers? So it can be handled by anyone who has been given this opportunity. It can be taken by leads, it can be taken by managers, or maybe delivery managers or project managers, or whoever has that kind of responsibility in the organization. So the next question is from Sumati, that when will we calculate the metric for product end of product delivery? I think I've already answered this question. The next question is, does this metrics work with agile process? What changes happen almost daily? Yes, absolutely. This is a very good question asked by Praveen Shetty, that we can use these matrices in agile also. In that case, the frequency of these matrices would be after every short release, and then the frequency might increase, but yes, this would do a good workaround for in case of the agile testing. Next one is, do we have any tools for matrix calculation? Aspect Durga, yes, there are lots of. There was a tool, I cannot recall the name, which had some inbuilt matrices, but it asks you a lot of data, and then you just feed in that data, and it would show you some kind of 360-degree evaluation of the matrices. So if you could just mail me a question, I can recall that particular name of the tool and let you know. Apart from that tool, there are lots of Excel sheets floating in the internet space. If you could search for a matrix template, then you can get some ready to use templates in Excel format. Ranjit is asking, do you have any standard formula format of matrices? So the format is just the matrices are just consisting of the formulas. You can actually use the Excel sheets, and then maybe you can put this formula in the form of an Excel sheet, and then use it as a template or a format. The next one is, can you ask question asked by Pankaj, can you explain test coverage matrix? So I guess Pankaj has left, but still the test case, the coverage matrix is how much coverage is done by the manual and how much coverage is done by the automation. So for example, in case of 100 test cases are executed and 60 are automated, so the test coverage would be 60. So Ravi Sinha is asking, does the method help in agile methodology? Yes, Ravi, I just explained. It helps a lot in the agile methodology also. The next question is from Shrikant, that since the number of bugs were considered to evaluate the performance of a tester, then it leads to create more invalid or duplicate defects. So what is the best way to measure the tester productivity and also reducing invalid defect reporting? So Shrikant, this is a very good question. So in some organizations, I've seen that the performance of the tester is depending on the defect only. So I would say that this is not a good practice to judge any tester by the number of defects he is reporting. There are other yardsticks to measure his performance. For example, you can use the test case productivity, the test execution productivity, see his other areas, see the other areas of the testers in terms of the creation of the test cases, the execution of the test cases, and the defects is one of the matrices, but in that also you should actually verify that how many valid defects were found by a particular tester and how invalid defects were found. But how many defects is not a good measure, and we do not encourage this kind of evaluation process by any company. Next question is from Neha, that in case of manual testing, it has 2,000 bugs. I guess this is a repeat question. I've already answered that question. So now this is the last question by Ravinder Joshi, that any methods for security testing. So security testing is a form of a normal testing only, wherein you are actually testing the security of the database or security of the application as such. So the normal matrices would work perfectly fine in case of security testing. There should not be any need of tweaking the matrices for doing a security testing. So I guess I have answered all the questions that came to me. And if there are any more questions, I'll just display my slide, my contact details. You can just mail me your questions and I would be glad to help you out. Thanks a lot for your time.
Thank you. Hello. I am really thankful to our guest speaker for conducting this webinar. It was indeed a great session. I would like also to thank to all my participants for their support in making this webinar a successful. The recording of this webinar will be available on techgig.com by tomorrow. Thank you all.